Good morning, Tahmina Khan is here in TKMaths A1. In today's video, which is video number 1 on momentum, we will make altogether 3 videos to complete the concept of momentum, which is a part of the syllabus of A-level mathematics. M1 9709 is the code. After 3 videos, we will make videos on past paper questions so that we can understand the application of the concept very well. So here are the QR codes for P3, S2 and M1 videos. So you can scan it to view more videos on maths if you're interested. So in momentum, we will cover 3 basic concepts. Number 1 is linear momentum, understood what is momentum itself, and then its vector nature, then changes in momentum, and then afterward conservation of linear momentum. And you can see coalescence of the bodies is a part of the syllabus as well, but impulse you will not need to understand here because it is not required. So I just put it down into pointer form here. So let's just start what is momentum first of all. So I have stated here in simple layman language also, or in mathematical language as well, so that you can understand. So let's see here, momentum is a commonly used word in sports. This is the first time students, mostly when we ask in the class, they give reference of this. That's why I have mentioned it here. So when we want to see the momentum, it is really basically how hard to stop a moving object basically. Then we say momentum is very big in that case. And in physics, it represents to the quantity of motion that an object has. I have written here already so that if somebody wants to make a note you can put the video on pause and take it. So now we have seen that measurement of how difficult it is to stop a moving object or mass in action. These are simple explanation of momentum. Now when we say linear momentum, we are talking about motion in the straight line in our course only, right? So mass of the object will be taken in kg and the velocity will be taken in meter per second. You know, the important thing is unit. So that's why momentum is mentioned as product of mass into velocity, and its unit is also ns, which is Newton second. If you want to know how come kg meter per second or Newton second, so I will explain to you in the next slide. Explanation is not part of the course, but for your understanding. Momentum itself is represented by a small p or simple p, right? It is a vector quantity. If you see, velocity is a vector quantity, mass is a scalar. So when scalar multiply by vector, the product is vector. So that's why it is vector quantity, momentum. And secondly, we are talking about motion in the straight line. So if it will be right hand side, we will take it as positive, and if it is left hand side, we will take it as negative. These are conservations, right? So now just to explain here very quickly why the unit of momentum is also ns, Newton second. So it is something related to Newton's second law of motion. I'm sure you all of you know what is SI system, but I have written it here for your information. If you want to read, you can. So you know that Newton's second law of motion is F is equals to ma, and another formula for the constant acceleration, v is equals to u plus at, you also know. If you make a subject from here, from this equation, it will become v minus u divided by t. And if you replace it here in place of a, it will become this, right? And when you cross multiply, it will become ft mv minus mu. Now what is mv minus mu? This is change in momentum. Final velocity, initial velocity, and multiplying by mass. So momentum, when you subtract, it is called change in momentum. And what is ft? It is force and time. Force is Newton, time is second. So this makes sense why the unit of momentum is Newton second, because momentum is equals to ft. Impulse we will not talk about here, so I'm not talking in that context. I'm simply talking about general term. in general term, sorry. So that's why momentum unit is also ns, otherwise it is kilogram meter per second. So I hope this has given you the clear understanding that why the unit of momentum is also ns. So this is just for your information, it is not required at examination level. So let's solve a very simple question first of all. This is video number 1, basic application. So if I look at the mass of the car, this is 1000 kg, perfect unit, and it is traveling at 30 meter per second. So this is simple, no unit conversion is required. You can straight away multiply it. So it will be 30,000 kg meter per second, or you can write Newton second, right? In the second question, what is important here to note down? Yes, the mass is not given in kg, so you need to change tons into kg first. Velocity is fine, 20 meter per second. So 30 kg is equals to what? 30,000, right? You know the conversion. So 30,000 kg. So now in the momentum formula, mass into velocity, you can simply substitute 30,000 times 20. And you will get 600,000 kg meter per second, or you can write Newton second. Now change in momentum I have already explained to you while I was telling you why the unit is ns. So here we will talk about one example also. So when we are using the word u, we usually mean by initial velocity, and we represent to final velocity. Okay. So in this example, if a body of mass 2 kg, when the speed changes from 6 meter per second to 15 in the same direction, what was the change in the momentum? So what you will do? Yes, very good. You will simply find out the momentum when the speed was 6 and momentum when the speed was 15, and then subtract the two. Now this is something very important when it is saying in the same direction, because we have seen above, if the direction is in the right hand side, we will take it as a positive, left hand side negative. This is not a compulsory rule. In vector, the important thing is opposite direction, opposite sign. This is just a conservation that right hand side is usually taken as a plus sign. Okay, so if I want to find out the velocity, momentum, it is what? 2 times 6 is 12, and this is, you can write here u if you want, no problem. 2 times 15 is 30. So change in momentum, if I want to write, I will say final minus initial. It will be equals to what? 18 meter per second. No, 18 is change in momentum, so it is kg meter per second or Newton second, right? Now this question you will do, and then I will show you the answer. Like I said, the direction is very important. It is something hitting the ground and then rebounds. So what will happen? I'm showing you the solution. If you're working, you can put it on pause. And another thing is, the weight is given in gram. You need to convert it into kilogram. So don't forget that. Why did I write minus 6? Because when something is hitting the ground, it was coming in this direction, then it was going up. So if I have taken the downward as negative plus, then upward as minus, right? So you have to decide your directions also. And now here I have given 3 questions to test your understanding or to practice more. Then I will end this video. I'm showing you the answers here. It's not the working. For question 5, because I've done this in my class, so because I solved question 5, so I said why not show that solution here. The rest you will try out yourself. Answers are given here. Okay, so thank you very much for watching this video. In the next video we will talk about linear momentum. And thank you very much for watching the video. Please press like and subscribe button and share it with your friends. Take care. Allah Hafiz.